Oh, okay. So my main target here is to explain this insulation and the heat budget because my question happened to be wrong in this section. So I will explain, oh, like all climatology, climatology portion. Okay. First, what do you mean by weather? Weather is simply डे टू डे वाइज जो भी लाइक टेम्परेचर होगा उसको हम कहते हैं, मतलब जो भी डे टू डे टाइम में जो भी लाइक एटमॉस्फेयर में जो भी टेम्परेचर उसको कहते हैं वेदर। क्लाइमेट जो होता है वो हम एज अ लॉन्ग पीरियड में कैलकुलेट करते हैं, और मेथड मिनिमम लाइक हियर इज गिवन दैट क्लाइमेट इज an average atmospheric condition of an area calculated over a minimum period of 30 years. This is the climate. Here you can get the idea of what is weather and weather is what is climate. After that we have the composition of the atmosphere. Composition क्या होता है? Simple, the layers of the earth's atmosphere. यही होता है ना, the layers of earth air surrounding the earth by gravity is called atmosphere. After that we have the composition of the earth's atmosphere. Atmosphere is thick gaseous envelope that surrounds the earth from all sides and is attached to it is to the earth's surface. ठीक है. After that we have the gases in the earth's atmosphere. As we know that हमारे पास जनरल एटमॉस्फेयर में अगर हम देखें हमारे पास हर कोई मिक्सचर ऑफ नाइट्रोजन है, ऑक्सीजन है, कार्बन डाइऑक्साइड है, बट here we have to remember the which gas is more and which gas is less. Like you have to remember, in you should have a general idea. Like nitrogen का यहाँ पे 78% है by volume, ऑक्सीजन का है 20% by volume, argon का है 0.93 and carbon dioxide का है 0.036. So you should have a general idea. Like if you see, can most abundant of all the elements on earth's surface is carbon dioxide. Generally if we can see that how, like हम इतना बोलते हैं कार्बन डाइऑक्साइड, वी आर रिलीज द कार्बन डाइऑक्साइड, बट स्टिल द नाइट्रोजन is in maximum percentage 78, like 78.8%. After that we have the nitrogen also, we have the like carbon dioxide also. Go through all those definitions. Noble gases we have, water vapors we have, dust particles we have, and ozone we have. ठीक है. After that if we go to the structure of atmosphere, structure क्या होता है? Simply if a human body have a structure, definitely our earth's atmosphere to have a structure. General way में if we can say that our earth's atmosphere have two parts, main two parts. One is होमोस्फेयर और द heterosphere. होमोस्फेयर में क्या होता है? सिंपल, जिसमें गैसेस मिक्सचर में होंगे, उसमें एक एक मतलब एक ही लेयर में, मतलब ऑक्सीजन भी होगा, नाइट्रोजन भी होगा, कार्बन डाइऑक्साइड भी होगा एंड अदर गैसेस भी होंगे. ठीक है. इन हीटेरो टाइप्स में क्या होगा? जो गैसेस के लेयर है ना वो ना एक दे विल फॉर्म ए डिफरेंट लेयर्स. एक लेयर में हाइड्रोजन होगा, सेकंड लेयर में क्या हीलियम होगा, थर्ड लेयर में विल बी सम अदर गैस. दिस इज सिंपल categorization of Earth's atmosphere into, like here if you can a difference between the homosphere and the heliosphere. General idea I have given you, and rest you can go through that. Similarly we have the homosphere and heterosphere are further divided into the, like in the homosphere we have troposphere, stratosphere and mesosphere. In the heterosphere we have the thermosphere and the exosphere. How you can remember, like main idea is to remember troposphere, stratosphere, mesosphere, thermosphere, and exosphere. What I have, like how I read them, like I have generally gone through multiple times: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. In that way, I have recalled them in the examination also. Maybe you have some other techniques to remember, but general way you have to remember the layers, different layers: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Is one more important thing is here is variation of temperature with altitude. Like you had to draw exactly, like in the examination there are, like most of the occasions they will ask you the variation of temperature with the different layers of the earth. Like you should have, like in the examination, at least like 1 to 2 seconds or 3 seconds you should have to draw this graph in, in a very fast to solve the questions. Have this one in the mind too. After that, you have troposphere, stratosphere, and mesosphere. Go through all those things because you all know and can Karmlin effect, Karman effect, sorry, Karman effect. It you can generally cover it in UN clause. Mein. UN in UN clause you can cover it. I can explain here also, but it will take a time. But I will cover it in UN clause also. Now coming to the insolation and the heat budget. Here we have the sun and we have the earth. In this, from the sun we can get incoming solar radiation. Like from the sun we can get the radiation which we are called incoming solar radiation. Okay, जो incoming solar radiation हो, the incoming solar radiation they have the high energy because they are coming from the sun. ठीक है, they have the high solar, like high energy. If they have the high energy, can we say that they have a short lambda or long lambda? As per the formula, E is like energy, E is equals Hc upon lambda. If the lambda is low, the energy will be high. ठीक है? Similarly, the radiation that we get from the sun has a high energy. It means that they have a small lambda. Like here, the incoming solar radiation have a short lambda, and we got incoming solar radiation. When these incoming solar radiation fall on the Earth's surface, some portion of the radiation will get reflected as it is. They won't get absorbed, but they get reflected as it is. Those reflected radiation are called, like those radiation are called reflected radiations, or those are also called albedo. My question happened to be wrong here. I was thinking that albedo is the like reflecting capacity. Like albedo, what I was thinking that when sunlight falls on anything, it the capacity of any body to reflect back the radiations. My now coming to the question, you have to remember that the reflected radiations or the albedo, they are the same things. They have the same energy as some simple similar way to the incoming solar radiations. Okay. Sim- the incoming solar radiation, the some portion of the incoming solar radiation are absorbed by the earth. Okay. When the earth is absorbed the incoming solar radiation, the earth gets heated up. Okay. After the when the earth gets sufficient heat up, they start radiating its own energy. These are called terrestrial radiations. These are radiation emitted by the earth's surface. They usually have a low energy. If they have a low energy, what we can say about the lambda? They have a high lambda, long lambda or high lambda. These are simple things. After that, you can go through this the amount of incoming solar radiation is called insolations and all those things, blah blah blah. After that, we have the greenhouse effect. We can say that when the atmosphere is transparent to incoming solar radiation, transparent energy because energy is more. If the energy is more, they can penetrate easily through the gases or whatever the जो भी मतलब उनके सामने होता है आता है वो इजीली उनको पेनिट्रेट करके चले जाता है. We can say that the atmosphere is opaque to the incoming and opaque to the outgoing terrestrial radiation. It is transparent. Atmosphere is transparent to incoming solar radiation and opaque to the outgoing terrestrial radiations. Outgoing terrestrial radiation क्यों मतलब opaque क्यों है क्योंकि they have the less energy. Simple. Warming of Earth's atmosphere by the absorbed terrestrial radiations. That's called a greenhouse. Simple way to warming of Earth's atmosphere by absorbed terrestrial radiations. The radiation emitted by the Earth's surface when they are like blocked by the Earth's surface. Because in Earth's surface we have gases, like clouds. We have gases and clouds. Those clouds and gases block the terrestrial radiation, which results the heat up of the Earth's atmosphere. Gas, like for example, like types of gases found in the Earth's atmosphere: carbon dioxide, we have methane, we have nitrogen oxide, we have HFCs, we have perfluorocarbons, we have sulfur hexafluoride, we have and water vapors we have. Okay. Now, modes of heat transfer. When some like when usually no, when we put the pipe on the fire, it will get heat up because there's a transfer of heat from one end to the next end. Simple way, if you can say the radiation. Solar, like incoming solar radiation, when incoming solar radiation falls on the earth's surface, it get heat up. It get heat up. That's called incoming solar radiation. Radiation through the heat transfer, that's called incoming solar radiation. Conduction, transfer of heat to the molecular activity at a zone of effect. Simply, if you can put the like any iron rod on like fire, that's called conduction. Transfer of heat through conduction. And convection may count the transfer of heat by vertical movement of masses. Conduction, simply you can say that when the incoming solar radiation falls on the Earth's surface, simple way you can say that जब Earth's body पे वो incoming solar radiation fall हो जाती है, वहाँ से वेपर उठने लगते हैं, वहाँ से वेपर्स उठ जाते हैं. This is called the simple example of convection. So advection, transfer of heat, a horizontal movement of mass. Okay. After that, we have the factor affecting the insulations. You can go through it. There's not much important here, but heat budget is important. Like heat budget, simply what we can understand from the heat budget is like whatever amount of energy is coming from the earth. Simple way, में earth is also reflecting same amount of energy. Whatever earth is getting, same amount of energy reflecting back back by the earth. Now how? Say that earth is getting 100 rupees of energy. Here you can see in the diagram, say for example earth is getting 100 rupees of energy. Out of that 65 rupee, like 65 earth is absorbed by the earth's atmosphere plus earth, and 35 is reflected back as it is. Q, why is it reflecting back? Because in the earth's atmosphere we have the clouds, we have the gases present, so they will reflect back some portion of the incoming solar radiation as it is. Okay. Now coming to the 65, which is absorbed by the earth's surface plus the earth. Out of that 65, 51% is absorbed by the earth's surface. Earth's surface, अर्थ पे जो लैंड पोर्शन है, ओशन पोर्शन है, ग्लेशियर पोर्शन है, दैट पोर्शन 14% इज एब्जॉर्ब बाय द एटमोसफियर. 14% एटमोसफियर का और 51% का जो प्योर अर्थ सरफेस है. इन दी अर्थ इन 51% जो हमारे जो अर्थ सरफेस में 17% is reflected back to the atmosphere. Reflect back to the atmosphere. क्यों? क्योंकि there are some, like we have the oceans, they have their albedo, because they when some amount of energy falls on them, they will reflect some portion of the light back to the earth's surface. Simply we have the glaciers, we have the snow, like glaciers, they have the snow, they will reflect some portion of the light back to the earth's surface as it is. So that will calculate total, that will calculate to the 17%. So 13%, like 30 out of 51, if we minus the 17%, we will get the 34%. Like 34 is absorbed by the earth's surface. So total kitna earth absorb kitna hua? 14 plus 13, how much it calculated to? 48%. Here you can see that 48 is the energy gradually released into the space. No, 34% is the energy transfer to the atmosphere, which overall add up to 34 plus 14. Here 34 plus 14, which is equals to 18. And here if you can see 35, 35 ye plus 17, how much it calculated? 35 plus 17, 12 plus 1, 3 4 5 62. हाँ ये आता है 62. 48 is energy gradually released into the space. The total energy released into the space is 48 released into the space. Sorry, I could not recall. I am conceptually wrong. Please correct me if you have a better concept. Uh, After that, we have the albedo also here. Usually, question will come on the which portion of the Earth's surface. Like we have fresh snow, ocean ice, new concrete, desert, which have the high which have the like highest albedo. You have to arrange them in the order. The question will come in, make the those in the increasing order of their albedo. Okay? Albedo you can got here from what is the albedo? It is the ratio between the reflected amount of solar radiation and the incoming amount of solar radiation by the Earth as a whole. Snow and ice has a high albedo. Asphalt and charcoal has a low albedo. Usually, ice they have the white, so like outer surface. They will reflect most of the like incoming solar radiations. The charcoal that's black in color, so they will absorb most of its incoming solar radiation. Albedo is directly proportional to the reflection of the light. Albedo is also called a reflection coefficient. The average albedo of the Earth is 35%. Albedo is helpful for the distribution of temperature. Temperature क्या होता है? Temperature is like degree of hotness or coldness of a body. Mean daily temperature is sum of 24 out of 24 hours temperature क्या कितना रहेगा उसको divide करेंगे 24 से that we get there we get the mean daily temperature. Okay, thank you. Please correct me about this heat budget because I am wrong conceptually here. I will try to get through back it, but